So today I wanted to cover what I think is a controversial topic, and that's the performance of array operations. Because we get in this idea that we think we're, for doing a lot of iterations, that there's no problem with doing one way or another. But the fact is that a lot of array operations are actually quite slow. Array, as I've proven in other videos, shift and unshift are extremely slow because of their nature, but pop and push aren't that bad. Pop being the winner in the sense of its ability to perform. So I wanted to run some tests on Array.pop, and as you can see here, I've got some tests set up. I went ahead and ran the tests ahead of time, and the real control for this is essentially you've got a standard for loop that you're going through the number of iterations that are in the array and removing them. The other one is a very typical way that you would iterate through the array, and you would actually use the array's length to identify whether or not you're finished or not. And then to make sure as kind of control, I said, well, I'm going to do the same thing, but I'm also just going to force a break instead of concern myself with the actual while loop. And then we also do another one where it's very similar, but we also use the length again as a measurement of comparison. And then last, the as a control is actually going in and using a really standard way of doing this, which is we're actually setting the value from the array as it's coming through, and then we're shrinking the array one at a time as we go, and to kind of just emulate what we would think that pop is actually doing. Now the results are quite interesting because when you look at this, you would expect. I mean, I actually at this point I don't even know what to expect, but it really boils down to there's some very interesting compiler optimizations that are happening behind the scenes. Now, I would say that these two right here, I've seen running this test multiple times, are quite similar. They, kind of come out on about the same. And what really started me to add this control test was I was seeing this one beating everyone. And as you can see, looks to be, aside from this one, seems to be the winner across the board on all of these tests. It's basically dominating everything, and that I think is quite strange, because first of all, you're doing a standard array pop, and at the same time, you're also making a call to the length and checking to see if it's reached 0 again or not. So there's got to be some compiler optimizations happening here where the compiler is identifying that array.length is being used and then caching that value in some smart way that's allowing this to outperform all the other ones. Because, for example, like in this case, I'm not even requesting for the length ever. I don't ask for the length of the array. I simply just call pop and I add it to the target array to make sure that in every case we add to an array, because we want to make sure that we're actually transferring a value so that the compiler doesn't get over smart and figure out that we're not actually doing any work, and then all of a sudden your test results are like, why is this into the billions or whatever? So let's walk through these and identify what's going on. You've got a standard for loop. It's one of the worst. It's down at the bottom. In fact, it is the worst of all the tests. Actually, never mind. We've got one even worse here. But let's keep going. It's just these tests in Firefox are really against standard theory. So what we have done effectively, again, is we've hunted for compiler optimizations, and we found them that by somehow identifying what you're doing simply, the compiler recognizes that, oh, there's some faster way to do this, and I don't know why. You would expect, according to theory, that not actually querying for the array length at all would be faster. You would expect that this, being a typical example of what is actually going on behind the scenes, would be the fastest, but it's not. It's actually the slowest. Also, what I did here is I wanted to test against examples of periodic checks against length and updating length instead of actually doing it every time. This is kind of a standard practice when you're modifying the overall results of things. You don't want to overdo it. Now, out of all these style of tests, like where I actually check against the lengths and set the lengths on a periodic basis, it's actually doing better the longer, which is what you would expect. You'd expect it that if there's a longer wait time before you actually update the array length, then you would be less time. But even what's strange is with not even having an if block in here, this is significantly lower. And I don't necessarily understand why. And it might be simply that Array.pop might not actually be updating the length of the array behind the scenes. It might be just picking the results from an ID and not actually shortening it. I don't know. But now to really add more to the controversy, we have the same results in Internet Explorer. And Internet Explorer is like completely the opposite, which is actually follows theory a little bit better, that the pop operations should be slow and that the subsequent other operations should be faster. Now, interestingly enough, these different operations where we're actually checking against the length don't really pan out. They seem to get greater and then gets a little bit less at the end. It's almost like there's diminishing returns over a certain amount, which actually should make sense as well. You almost want to just pick a nice number and go from there. And then we've got this interesting thing happening where the most performant is a simple for loop. So I, again, am seeing a case where I believe behind the scenes there's some compiler optimizations that are happening inside of Internet Explorer that like the for loop. And then also, what's another interesting thing is that this is analogous to this as well, in a way that these pretty much are kind of similar. One just doesn't use pop, and it seems to be going up there and also being this is also the second fastest one. So I'm challenging people here to theorize or maybe even tell me why this is happening. And then what we need to do is really make a decision about what's the right way to do this. Now again, I'm only referring to pop, and I'm also using a very high number of iterations. I'm using 100,000, an array of 100,000 records to test these tests. Different sizes of arrays may behave differently just because of the nature of how arrays are built behind the scenes. So again, I'm challenging somebody to tell me what's going on. Tell me why one browser is doing one thing better than another, what their compiler optimizations are. And then there's the answer of, should we really care? Should we just, since pop seems to be reasonably effective, should we continue to use it, or should we keep trying to reuse the length value, which is what I've been trying to do more in my own code, because I believe that, depending on how complex your loop is, these optimizations might not actually be in place. Simple loops where the compiler can see the loop and then see what you do inside the loop, I believe is where optimizations occur. But in places where you might have complicated logic where there isn't an actual loop, then you can't be sure if there's actually going to be a compiler optimization. So I typically will fall back to the standard way of doing things. So again, tell me what you think. See if we can solve this puzzle.